Good morning, class. Welcome to the online classes of physics for class 11. In the previous videos, we were learning about the chapter force and the laws of motion, in which we have seen the three laws of motion and what is the force and the types of forces, and we have even seen what is momentum, conservation of linear momentum, and many more things. In which last session we have seen the topic that what is apparent weight. What was the apparent weight? That whenever the body is moved vertically downwards or vertically upwards, then we feel some changes in the weight, and this changes is due to the reaction force that is experienced by the man. So this is a reaction which is given by the, and what we have learned in the third law, that every action has an equal and opposite reaction, or we can say that every force has an equal in the magnitude but in the opposite direction force. So this force experienced by the man during a direction in the vertically upward or in the vertically downward is said to be the apparent weight. So this weight or the force experienced by the man is said to be the apparent weight. And we have seen that when a person is in an elevator or in the lift, whenever the lift move upwards with the acceleration a, then what it means that we are moving in the upward direction. So we feel that our weight is also increased, right? Our weight, we feel it as that our weight is increasing. So this upward force together on the man is said to be that mg and r in the opposite direction. So we can say that r minus mg will be equals to mass into acceleration. From here we have seen that the reaction force is equals to the mg plus a, that is we are thinking that our weight is increasing, so that is the apparent weight of the man is increased. And similarly, when the lift moves downward or the elevator moves downward, then we can say that the acceleration is decreasing. So acceleration is in the downward direction. So g and m will be in the same direction, but we can say that mg and r are always in the opposite direction. So it is given by mg minus r equals to ma. So on taking this reaction, we can say that r is equals to mg minus a. So this is the apparent weight of the man when it is inside, and when it is vertically downward, so we can say that the apparent weight feels to be decreases. And when the rest or in the when we can say that it is moving at the uniform velocity v, or it is said to be that it is at the rest position, then we can say that acceleration is 0, because at the rest position the velocity is not changing, and if it is moving at uniform velocity v, then also the acceleration is not changing, so acceleration is 0. So taking a equals to 0, we will only get that the reaction force will be equal to that of the weight acting in the downward direction. So apparent weight will be equal to that of the actual weight itself. And when the freely falling body, if it is freely falling, then we can say that the only force acting on the body should be of the gravity itself. So what we feel is that it is a weightlessness, that our weight is not there, we feel that our weight is already completed. So we can say that if we feel the weightlessness when we are freely falling body is there, then the gravity is working. So a will be equals to g, and g minus g will be 0, that is reaction force will be 0. So the no weight or the force will be acting on us. So next thing we have read that what is the conservation of linear momentum, that is momentum before collision is that is equal to the momentum after collision. So momentum can be said that it is conserved, that is total momentum before is equal to total momentum after collision. So this is what the conservation of the momentum is. And similarly we have seen the application also, that is rocket propulsion, and similarly the second one was the recoil velocity of the gun, right? What the recoil velocity of gun was, that whenever the bullet is fired from the gun, that the bullet moves with some mass and the velocity. Now the mass of the bullet is small m and the capital M with the mass of the gun, then whether the mass of the bullet will be m and it is moving with velocity v, then the momentum is given by mv. And similarly the mass of the gun is capital M and the velocity be v, then it is given as mv. Here the velocity of the gun, that is due to the momentum conserved, that is the bullet is moving in the forward direction, so it will give a action or the reaction, we can say that the opposite force will be acting in the backward direction. So the gun gives a jerk in the backward direction. This jerk is due to the velocity, that is recoil velocity. It is said that the velocity is to be the recoil velocity of the gun, which is much smaller than that the forward velocity. It's too small because we're just getting a smaller jerk. If we take that equal to that of the forward jerk, then we can not bear about that gun's velocity, right? Because bullet moves with the highest velocity, so the recoiling will be less than that of the forward velocity. Okay, so here see a numerical regarding the recoil velocity, that 30 kg cell is flying in the 48 meter per second. When it explodes, its one part of the 18 kg stops while the remaining part flies on. So find the velocity of the latter. So we can say that the mass and the velocity is given, so we can find out the momentum. And similarly the other one is that one part is 18 kg, right, and it will stop, so the velocity will be 0 because it is going to stop, and the remaining part flies on. So here the remaining part is having some velocity, but we don't know the velocity of the second part, and the first part will be of 18 kg. Okay, so we know that the other weight will be, because at 30 kg cells, so the next weight will be 12 kg. So we can say that one is 18 kg and the other one is 12 kg. So the momentum of the remaining two parts will be 18 into u and that one is 12 into u, and 18 into u is just stopping, so v will be equals to 0. So 18 into 0 it will be 0 and other one will be 12 into e. So from here we can find out the velocity of the second part. Okay, so there are many, you have seen this numericals in the last class also. If you think this, that the car of mass 1000 kg is traveling at 32 meters per second, dashes into the rear of the truck of mass 8000 kg moving in the same direction with velocity 4 meters. And what is the velocity of the truck after the impact? Here the collision is elastic, because as it collides, the truck is of the highest momentum, so it will just give a jerk to the other car and it bounces back with velocity 8 meters per second. So here we can say that it is a elastic collision, so it is given as m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. From here we can find out the velocity that what the truck have after the impact. So in today's session we are going to learn about the new topic, that is the equilibrium of the concurrent forces. What does concurrent force mean? That in many of the parallel forces or the different forces acting at same point on a body are said to be the concurrent forces. So what this equilibrium means? Whenever we know that the balanced or the unbalanced force, what it was, that when the balanced forces are acting on a body at some point, then the resultant force or the net force is 0, then the body is said to be in the equilibrium, and the force acting on the body is said to be balanced force. So the net balanced force, if it is not 0, then it is said to be unbalanced force. So here the concurrent forces, when the number of the force acting on the body at the same point, the net unbalanced force or any other forces acting on the body will be 0. So what did happen? That the body will continue in its state of rest or in the state of motion. Cannot change state and rest, because we already know that the unbalanced force is allowed to change the state of rest or the motion, but the balanced force does not. It just changes the size and the shape of the body. So it is allowed to move in the same motion or in the same rest. So the concurrent forces can be given as like this. In the diagram you can see that the three concurrent forces are there, F1, F2 and F3. If these three are acting together at a point O, then what we can take this equilibrium. Here see, if it is F3, F is just extend it in the opposite direction, what it will be? F3 in the opposite direction. See, this figure is similar to that of the parallelogram law of vector addition, which we have learned in the motion plane. Right, so from there if you see, then it says F1 plus F2 is the negative direction of the F3. So the resultant is given in the direction opposite to that of the head of tail of the F1 and F2. In this diagram we can say that the direction of the F2 and the F1, so these are in the same direction, that is the head and the tail of the other one. So we can say that they both are in the same direction, but we can see that the F3 is in the opposite direction. So we can say that F3 is equals to minus of F1 plus F2. So axis of the body says that F3 is equals to minus F1 plus F2. Then only the body can be in equilibrium, because both the three forces will be acting together at the same point and the balanced resultant force should be 0. Then only the body will be in equilibrium. So F1 plus F2 plus F3 will be equals to 0. And similarly, if we take this B figure, then what we can say here, that F1, F2 and F3 are in the triangle law of vector addition, right? We can just compare it with the triangle law of vector addition. So here also the point will be, that is the sum of all the forces will be 0. So this is the concurrent forces acting at a point, but for the equilibrium, the resultant forces should be of a balanced condition, that is the resultant force sum should be equals to 0. So the forces F1 and F2 and F3 can be represented in a triangle ABC, taking in the same order. So this is, let us take this F1 and F2, 3 are acting on the same point, that is O, and the angle between these two forces are named as, that is F2 and F3 is named as alpha, then F3 and F1 is named as beta, and F1 and F2 between the angle between these two forces is given by gamma. So these three forces are given. Now if we are just taking it as a triangle, then we have to change it with the 180 degree, right? We have to move it, so it will be moving in the 180 degree. So it can be written as pi minus theta, that is pi minus alpha, pi minus beta and pi minus gamma. So taking in the same order, if we take the sine of the triangle ABC, then what we can write it as, that F1 will be sin pi minus alpha, and for F2 it will be sin pi minus beta, and for F3 it will be sin pi minus gamma. So together we can see here in the figure that pi minus alpha, pi minus beta and pi minus gamma. So the opposite angles to the side are equal, so that's why F1 upon sin pi minus alpha will be equal to that of the F2 upon sin pi minus beta, and F3 upon sin pi minus gamma. So for sin pi minus theta, there is 180 minus theta will be same. That is 180 minus theta, sine will be taken as the same angle, that is theta will again come. So we can take it as sin alpha, sin beta and sin gamma. So this is what the law given by the Lamy's theorem. So this is named as Lamy's theorem, which states that if the force acting on a particle is in equilibrium, then each force is proportional to that of the sine of the angle between the two other forces. So these are the formulas which we have used in this theorem, that is Lamy's theorem, and the three concurrent forces, and if the balanced forces are acting on it, then the net force or the sum of all the forces should be 0. That is, the resultant force should be 0, and the net forces should be equals to 0, then only the body is in the equilibrium position. So see this figure, and remember, resolving a vector, we can say that the horizontal vector is always the cos theta and the vertical vector will be given as sin theta. So mass of 6 kg, remember, every time whenever a body is kept, always whenever it is suspended, then the weight is always acting in the downward direction. Similarly, it will have a reaction in the upward direction, which is given by R. But if it is suspended with some wire, let this be a wire, then it have some tension which is given as in the opposite direction. So this tension and mg will be in the opposite direction. If you write it together, like T is equals to mg, and for equilibrium position, what it is given as T minus mg is equals to 0. This is about the equilibrium position for the force. Okay, that is tension. So here also we were using the same thing, but we have to see that which forces are acting, are making it in an equilibrium position. So we will be taking it as components. So we are resolving this forces into the tension into its components. So here we have seen that 6 kg mass is suspended by the rope of length 2 meter. So here the rope is of length 2 meter. That is, rope is of length 2 meter and a mass of 6 kg is suspended through it. So some tension will be working in the opposite direction and the mass will be in the downward direction. That is, mg is downward, but this mg is equals to 6 kg. It is given that it is 6 kg and the tension is acting in the opposite direction. Now the next thing, a force of 50 Newton, that is, a force of 50 Newton in the horizontal direction is applied at the midpoint of the rope. Let this be the midpoint, that is at 1 meter, because the 2 meter is used as a rope. So we are taking its midpoint, so it will be 1 meter rope will be there. So what is the angle of the rope makes with the vertical point, right? Vertical point, what is a vertical in equilibrium, and we are taking g as 10 meter per second square. So we know that whenever the tension is acting, then we have to resolve it into components. Now what will be the components? That is t cos theta and t sin theta. Now we are taking that with the rope in the middle point, we are giving a force of 50 Newton, that is T is equals to 50 Newton. So this force, if we are just rotating it, what we can say that the horizontal component, this component will be given as T cos theta, and similarly its vertical component will be given as T sin theta. So on resolving the force, what is the angle? This is the resolution, right? This is the resultant vector. So let this resultant vector is making an angle theta with the tension line or with the rope. So 1 meter will be given as the rope's midpoint area. So this will be the vertical component, other one will be the horizontal component. So it is given as T sin theta, and here it is given as T cos theta. So T sin theta and T cos theta. What is T sin theta will be equals to, because this T sin theta and this T equals to 50 Newtons are taken in the just opposite direction. They are just balancing each other. So we can write these forces as equal. That is, T equals to 50 Newton is equals to T3 will be equals to that of the T1 sin theta. Since the midpoint of the rope and the angle theta will be the vertical in the equilibrium, right? This is the vertical equilibrium angle. And taking this resolutions of the horizontal and vertical components, then we can say that the T1 sin theta is just balancing the other force. T is equals to 50 Newton. So we can write it as T1 is equals to, that is T1 sin theta is equals to T3. And here we know that T3 is equals to 50 Newton. So T1 sin theta is equals to 50 Newton. Okay. Similarly, the T1 cos theta is equals to that of the weight acting in the downward direction. So both are in the downward direction balancing each other. So we can write it as T1 cos theta equals to 6 kg. Okay. So these are the force, that is T1 sin theta is equals to 50 Newton and the other one is 6 kg. And that is, we can write that it is 60 Newton. And why it is given? Because mg, right? Mg is taken as the force. So mg, we can take it as mass as 6 kg and g as 10 meter per second square. So it is kg meter per second square, that is Newton, will be given as 60 Newton. So T1 sin theta was equals to 50 Newton and T1 cos theta was given as 60 Newton. Okay. So So we have seen that T1 sin theta was equals to 50 Newton and T1 cos theta was given by 60 Newton, and the one is 50 and another one is 60. So on dividing this both equations, what we can find out the angle, right? Angle can be find out. Because we have to find out the angle the rope makes with the vertical on the equilibrium. This is the vertical equilibrium, right? So we are taking out the angle with the vertical equilibrium. That's why we have taken like this. Otherwise you have to take just the horizontal vertical components. That is the resolution of the force or the tension on that rope. So on taking this division, we can find out the angle that tan theta is equals to tan inverse of 5 by 6. Okay. Similarly, see the next question that is given that a ball of mass 1 kg hangs in the equilibrium form two strings, that is OA and OB. It is given as is shown in the figure. What are the tensions in the string OA and OB? We have to find out the tension on the string OA and OB. So what it is given as that we are having the two strings that 1 kg at hanging from the strings, that is from OA and OB. We have to find out the tensions, that is T1 and T2. Okay, and the mass is acting in the downward direction. So both the strings we have taken where this mass of 1 kg is hanging in the equilibrium. So both will have to balance it, right? So here the three forces are acting, that is the weight is also there in the downward direction, that is mg, and the other is T1 and T2. Since the various forces acting at a point and the three forces are in equilibrium condition, because these two threads through which we are just hanging this object should be in the equilibrium with the third one. So we can say that these three are in the equilibrium position. So when three forces are to be concurrent at a point O and should be in the equilibrium, then we are using Lamy's theorem. What it was, that F1 upon sin alpha is equals to F2 upon sin beta, that is F3 upon sin gamma. So it is given as sin 150, that is T2 and T1, and again T2 and T3, and T2 and T1 is given as beta and T1 is given as gamma. So we are taking this values, that is T1 upon sin 150 equals to T2 upon sin 120, and mg, that is the other force in the downward direction, will be given as 1 kg, mass m is 1 and g is 10 meter per second. So together it will be 10 Newton. Net Newton force is acting from the mass. So sin 120 will be equals to that of 10 upon sin 90. Okay. So together on solving this, we got that T1 is equals to 10 into sin 30. Similarly 10 into sin 60. On putting this value, we got the Newton, that is the tension on the strings of the both the points, that is on hanging the mass of 1 kg from these points. So body of mass m is suspended by the two strings taking an angle alpha and beta with the horizontal directions. So here also we can find out that the free body diagrams, we are using that if a body is suspended with mg and this alpha and beta are made, then what is the strings weight? So what is the tension at the springs due to this weight? So taking the horizontal and the vertical components of this figure, what we can say that this, if we are taking the horizontal and the vertical component, this will be the what? This is T2, then its vertical component will be this, and this is the horizontal component. Then for T1, this is the horizontal component, this will be the vertical component, right? So on resolving this, we got that this is the vertical component for both the angles, that is sin alpha and again for sin beta, and this will be T2 cos beta and this will be T1 cos beta. So what we can say that these T1 cos alpha and T2 cos beta will be that of equal, they are in the equilibrium condition, so we can write in together. And after that we can see that all the vertical components, that is T1 sin alpha and T2 sin beta, are acting in the same direction. These vertical components are same because this is the horizontal component, they are balancing each other, but the vertical components are acting in the same direction. So we can write it as T1 sin alpha plus T2 sin beta will be equals to that of the weight acting in the downward direction. So this is balancing mg. So T1 sin alpha plus T2 sin beta will be equals to mg. Okay, and what we have to find, that we have to find out the tension. So on taking this value T1 and putting that value in the second equation, we can find out the value of tension, right? We can find out the value, that is T1, we have already find out that T2 is equals to T1 cos alpha upon cos beta. So putting that value in the second equation, T2's value, we can find out the equation. So on taking this, we are getting that sin alpha cos beta, this is C in the downward direction, we can say it in the denominator, it is sin alpha cos beta plus cos alpha plus sin, there is sin A cos B plus cos A sin B, which is the formula for sin A plus B. Okay, so mg cos beta upon sin A plus B. From here, if we find out T1, if we are putting the value of T1 here, we can find out the T2 also. These are the two values for the tensions on the string A and B due to that mass 1 kg mass suspended by these two strings. Okay. So now we are going to see that what is the motion of the connected bodies. So here we have seen that whenever the body is there, then the reaction force is always acting in the opposite direction to that of the weight. That is mg if is the weight, then the other force is the reaction force, and if these are in the equilibrium position, the resultant force should be equals to 0. So we know that if the bodies are connected together, if the number of the bodies are connected together by the strings, rods, or by the pulleys, then it is convenient to draw the free diagram. This is what the free body diagrams, okay, like the strings, tension, and giving the weight is the free body diagrams for each body separately by showing all the forces acting on it. Okay, by giving all the forces acting on it, that is weight, tension on the body due to this weight, and acceleration, all the forces acting on it can be seen by the free body diagram. And on equating this, we can find out the net force acting on the body due to this mass and due to the acceleration produced there. Okay, so this is what the motion of the connected bodies. So by drawing the diagrams for each system, all the forces acting on the body is said to be the free body diagram, which can be seen like this, that is tension, force, mg, accelerations, direction, all this together if it's shown in the diagram, that is the free body diagram. So here we have considered that there is a pulley, and this is allowed to be hanging with the two masses given as mg1 and the mg2. The other mass is given as capital M, the small m is given as for the first one. Okay, so it is given that this is the mass mg and this is connected to the other mass, that is capital Mg. Then the tension should be act in the opposite direction to it, right? This tension is acting to the opposite direction. Now we know that whenever the pulley is heavy object is kept, then that side the pulley will move. So we can say that the move downwards and lighter mass will move upward, because the heavier mass will always move in the downward direction. So this is the heavier mass and this is the lighter mass. So this will be in the upward direction, this will be in the downward direction. So what we can say that here the force is given as mass into acceleration, weight is given as mg, and tension will be for the reaction force, that is, or the tension on the string or the rope, because we are talking about the connected bodies. So these bodies will be tried to hang from the string, ropes, or the threads. So here we will be using that. We know that since the body is moving upward, that is MA is acting in the upward direction and the MG is acting in the downward direction. So the tension T and the MA both are in the opposite direction, that is on the upward direction. So T plus MA are together, and what it is equals to, it is balancing mg in the downward direction, so it will be equals to mg. So on taking the T's value, what we will be getting, that mg minus ma. Or if we are taking the value of the ma, then we will be getting T minus mg. Okay, so for this is how we have find out the value for the upward direction. Now for the downward direction, see, acceleration will be downward because the body is moving downward direction, so the acceleration will be in the downward direction. Now acceleration and mg both are in the downward direction. We can write it as ma plus mg, which is equals to the tension force which is acting in the upward direction. So from here we can write it as ma is equals to T minus mg, and in the last equation we got mg minus T. So together, on equating this both equations, we can find out the tension of the string and the acceleration also. Okay, so on adding this equation, what we will be getting, T will cancel each other, so it will be mg plus small mg, capital Mg plus small mg, that is minus, it will be minus mg. This will be equals to that of the two masses ma plus small ma. So together we can find out acceleration, that is capital M plus m, and here if it is g is constant, then a capital M minus m if we are taking the common. So what is the value of acceleration will be, that is m minus m upon m plus m into g. So this will be used for many formulas. You can even directly use for the acceleration of the two connected bodies. Okay, and similarly, if we have to find out the tension, then on dividing the equations we can find out the tension, that is 2mm upon m plus m into g. So this was the tension and the acceleration on the body for the two connected bodies at a point. Similarly, we have to find out the questions so that you can understand more better or get familiar with the tensions on the strings and the free body diagrams. See here, first question, that is a pull of 15 Newton is applied to a rope attached to the block of mass 7 kg by lying on the smooth horizontal surface. So mass of the rope is 0.5 kg. What is the force exerted by the block on the rope? By the block on the rope. Okay, so here what we are taking, that the two masses are there, Now we are seeing what is the force, right? Force is equals to mass into acceleration. So what is the formula for the mass into acceleration will be? We have to find out the acceleration then. And force is given that is pulled with a 15 Newton. So we know that it is a 7 kg mass which is acting in the downward direction. So it is mg. And we have to find out the force which is equals to mass into acceleration. Mass is already given 7 kg. And for acceleration we have to find out the acceleration. So from there we can just use what the acceleration will be, and again on multiplying it to the mass of the rope we can find out the force exerted by the block on the rope, because what is the weight for the rope is it will be used. Okay, so we are taking the force F. This is F, it is acting in this direction, and this will be the weight's direction. So acceleration is produced in the block produced in the block on applying by the force of 15 Newton. So we can say that the acceleration and weight is together added. So from here what we can say that m or g and m or a, this g will be equal to that of the acceleration itself, because it is not hanging but it is kept at the smooth surface. So it will be equal to that of a itself. So it will be ma itself, but one is the mass of the rope and one is the mass of the body. So it will be 7 plus 0.5, it will be kg, which will be equal to that of the force applied by the pull action. So it will be equals to 15. So on solving this we have got that the acceleration is 2 meter per second square. So on multiplying it to the mass of the block, then we can get the force by the block on the rope. If you have to find the force on the rope by the block, then it will be mass of the block, and if you take out the force exerted by the rope on the block, then it will be mass of the rope. Okay, so see the next question. It is given that the two blocks of mass m1 and m2 are kept in the contact, and here also the mg will be taken as acceleration itself. G will be not there, okay, because it is not hanging. For the hanging object, G will be there. If two blocks are always in the contact, what is the force at their common interface? What is the force? That is mass into acceleration, and acceleration is given by the force upon mass, and here the masses are kept together, so it is given by m1 plus m2. Now m1 is exerting force on the block of mass m2, right, because it is pulled right together with, they are pulling out with force F. Then the one block will be kept force to the other block. Then what it is given as, that is mass m1 will be putting the force equal and opposite force to the block. So the block will have the same reactional force again. So that as the block mass m2 has an acceleration will be given as m2 into a, that is m2's mass will be due to the mass m1. So we can say that the force on mass m2 due to the mass m1 is given as m2 into a, that is m2 F upon m1 plus m2. That is, a mass will be taken as the mass of both the objects, because they are kept in contact with each other after, because it is written that the blocks are always in contact. Then what is the force at their common interface? So that m1 and m1 plus m2 will be there. But now whether the m2 is having the force, but it is due to the m1, so that force is due to only m2, that's why it is m2a. So now the question is that if the three blocks are now connected together and we are taking a force 50 Newton, m1 and m2 is given, what are the tensions T1 and T2? Now since the force is acting on the object, that is m3 towards the m3, so that reaction force will be T1. Okay, T1, first mass which is hanging in the downward direction will have the tension T1, reaction force will be there. And now again what this T1 will do, it will prepare a tension in the m2 also. So in the direction opposite to the direction of T1, T2 will act, and T2's reaction will be given by the m3, that is T3 will be given, and T3's reaction will be due to the force acting on the first object, that is m3. So the tension in T1, T2 will be due to the masses together, right, because they are kept in contact with each other. So m1 plus m2 plus m3. So acceleration will be given by force upon m1 plus m2 plus m3. Now for the tension T1 string on T1, it is given as T1 is equals to m1a, that is mass m1 and the acceleration, which we have found in the above equation. And to determine the T2, we know that T2 is the force acting towards the m2 and m3 together, right, and we have to find out on the T2 tension. So we will be taking together both the masses, but m3 is taking T2 because T2's force is equal or balanced towards the m3 direction. So it will be equals to F will be equals to that of m3a, that is m3's acceleration in the same direction. So m3a is equals to t2. So m3a will be equals to that of the t2. So the m3 minus t will be equals to force. So I can find out the tension at the spring due to these masses. Now the G was not taken under gravity, because now the force of gravity will be taken under influence, because if the body is hanged, so 3 bodies are shown in the figure, are there hanging with mass 2 kg, 3 kg and 5 kg. So if there are tensions on the string will be T1, T2, T3, then they will have the reaction force also. So first of all we are finding the tension on the string due to this 3 masses together. So what it will be, that mass T1 will be due to the 3 masses together at m1 plus m2 plus m3, but the acceleration will be due to the gravity. So mg will be used. So this mass will be given as g, and g's value will be equals to 9.8 meter, or is given here 9.8 meter per second square, and acceleration it is given as 2 meter per second square with an acceleration of 2 meter per second square. So we have to find out the whole system's tension due to this masses with the acceleration 2 meter per second. So both will be there, that is acceleration as well as a gravity. So tension T will have together, that is 5 plus 2 plus 3 and 2 plus 9.8. Together we can, that is 118 Newton, because these 3 masses are acting together. For tension 2, that is second string will be taken due to the mass m2 and m3. So it will be m2 plus m3 a plus g. And tension on the mass T3 will be given as m3 a plus g, that is 3 into 2 plus 9.8. Okay. So now see the other one, that a body m1 of mass 10 kg is placed on a smooth horizontal tip, is connected to a string which passes over the frictionless pulley and carries at the other end. So body m2 of mass 5 kg is there. What acceleration will produce in the body when the nail is fixed on the table to remove? Now what will be the tension in the string during the motion of the bodies? What when the body stop? Now what will happen when the body stop? So Newton's second law, we know that the masses acting on the force acting on one body will be equal to that of the second one. Here see that the mass m2g is acting in the downward direction, and similarly the m1g is also acting in the downward direction. So tensions will be in the rope due to this reactions, and mg will have a reaction force also, and the tension on the string will also be there due to this mass m1 and m2. But the question was, what acceleration will be produced in the body when the nail fixed on the table is removed? When the nail is removed, so we can say tension of the body is to move with the acceleration a in the direction. So because this a will be in the downward direction, because nail is already taken out from there, so nail is removed, so they will be moving in the downward direction where the weight is pulled out. So from the Newton's law, what we can say, that the force acting in this m2 will be equal to that of the both the masses in the, that is m1 plus m2. So it will be equal to force is equal to mass into acceleration. So mass is due to both the masses, that is m1 plus m2, and into acceleration will be equal to that of this masses hanging down due to this pulley, that is m2g. So both together we can written as m2g upon m1 plus m2. From here we can find out the acceleration, and on the tension m1 we can find out that m1 will have a tension of 32.7 Newton. Now what is asked, that what will be the tension in the string during the motion of the bodies? This was the motion. So when the bodies will stop, what will happen? That is the velocity will be 0. So velocity will be 0, then the acceleration will also be 0. So what we can say, the tension in the string and the net force will be 0 itself. Then we can write that the force is only due to the mass m2, not then due to the m1, because it is not moving, the pulley is not moving, and then no friction is also there. If the friction is there, then we have to take out the static friction, limiting frictions, right? Static limiting or kinetic limiting frictions, but here the friction is not there, because frictionless pulley is used. So the mass m2 will only have the force on that body, that is m2g is taken. Okay. So now the next thing, that whenever the body is moving in a circular path, then it is having some force that it is allowed to move in the circular path, and it is towards the center, right? Because the force will be towards the center, because whenever we used to rotate any object in the round shape or in the circular shape, if we are taking it in the circular path, then we used to apply a force, or the force is to be influenced in the centered to point, right? Centered point. So this centered point force due to this circular path is said to be the centripetal force. So centripetal force is due to the center itself. And what the derivation or the formula for the centripetal force? So we can write that when a body is in uniform circular motion, its velocity changes, right? Because we can say that the uniform circular motion is an accelerated motion, because each and every time whenever a body is circulated, then it is rotated with some velocities, it is accelerated regularly. So we can say it is an accelerated motion. So here we have learnt in the last chapter in motion in plane that centripetal acceleration was there, and in that we have used the angular velocity also, that is omega square r was used, that is a is equals to omega square or v square by r also was used. So from there we can find out that force is equals to mass into acceleration, that whenever a body is moving in the circular path, then centripetal force is required to move that body in a circular path, and moving that body, then force is equals to mass into acceleration. This acceleration is the tangential acceleration that is acting in the circular motion, that is given by centripetal acceleration, and centripetal acceleration is equal to v square by r or omega square r. So we can write the centripetal force as mv square by r or m omega square r. So whether we are rotating an object by tying it to the thread, then also tension is there, and it is the centripetal force. Or planets, or we can take it the car is also moving in a circular track, or we are jogging in the circular track, or we are allowing a bike to rotate in a circular track, then the central force is named as centripetal force. Okay, so it is allow the body to move in a circular direction. So this is what the centripetal force is. And if you put the value of omega, that is 2 pi nu or 2 pi by t, we can find different values for the centripetal force, or we can find out different expressions. So if a string breaks under a load of 4.8 kg, a mass of 0.5 kg is attached to one end of the string, 2 meter, and is rotated in the horizontal circle. Calculate the greatest number of revolutions that the mass can make without breaking the string. So here we can say that the force will be acting on the string because it is tied with a load of 4.8 kg. So from here we can find out the force acting due to the mass, that is mg can be found out. Mass is given as 4.8 and g is given as 9.8 meter per second square, that is acceleration due to gravity. From here we can find out force. Now it is moving in the horizontal circle, so centripetal force will be working on it, which is given as mv square by r or m omega square r. But here the horizontal circle, no velocity is given, no angular velocity is also given. So we can find out that pi 1 because 2 pi by t or 2 pi nu, but it is rotation and the number of revolution is asking, so nu will be taken. Okay, that is frequency number of revolutions per second. So from here we can write it as m, that is omega is equals to 2 pi nu, so it will be mr 2 pi nu whole square, so 4 pi square mr nu square. So from here we can find out nu's value, that is 1.102. okay, 1.102 revolutions per second. So it is the unit for the frequency. We can write it as hertz also, but here the number of revolutions per second, because it is asked in the question that what calculate the greatest number of revolution. So number of revolution is given as a frequency, so we will be using the formula for frequency. Similarly, say the next one, that is a ball of mass 0.1 kg suspended by a string 30 cm long, and the string is always thought. The ball describes a horizontal circle and with the radius 15. Now we have to find out the angular speed. What is angular speed? Is omega. So we have to use the formula m omega square r. So here mass is also given 0.1 kg, omega is also given as omega, we have to find out, or it is given in the question. We have to find out, that is angular speed we have to find out, and force is given by mg, that is 0.1 into 9.8 or into 10, and string's length is also given and the radius is also given 15, so m omega square r. So from there we can find out the value of m, and omega square will be equals to that of under root f upon mr. So mass is also given, radius is also given, and the force we can find out by the mg. So m will be mass of the string, or the mass of the object that is tied to the rope, and g will be the acceleration due to gravity. So these are the applications for the circular motion, as centripetal force and the centripetal acceleration. The circular motion of a car on a level road, right? When the car is allowed to move in a curved level road, then the force of friction within the road and the tires provide the centripetal force, right? Because force is obtained towards the center. So the consider that the weight is mg, then we can write out the centripetal force and the maximum speed with which it can move if it has some friction mu. So we can write it as F1 and F2 with the forces of the friction that is given to the tires by inner and the outer surface. Then it is given as F1 mu R1 and F2 mu R2. So from figure you can see that F1 and F2 are the inward and the outward forces on the tire, because it is moving in the curved, right, curved motion. So when it is moving, so one tire will be in the inward direction, one will have the outward direction. Again when it moving in the different direction, then the other one will have the outward and the first one will have the inward direction. So both will be taken as F1 and F2 frictions, and the reactions will be R1 and R2. So on adding this both the total normal reactions, it will balance the weight of the car. So R1 plus R2 will be equals to F1 plus F2. So mu will be coming, that is the frictional limiting friction. Okay. So for the maximum friction, we can write it as mu into mg, that is R1 plus R2 will be balancing the weight, so it will be mg. So instead of R1 plus R2 we can write as mg. So mu mg should be more than that of the centripetal force, then only the car can stay on the road, otherwise it will move down. Okay, so the mass, that is mg, and the mu, that is limiting friction, should be more than that of the centripetal force. So from here we can write that v square by rg should be less than the frequency. So here we can write it as maximum speed of the car should be equal to that of under root mu rg. Okay, now circular motion of a car on a banked road. Now if a system is raising the outer edge of the curve and it is inner edge is called the banking, right? It is called the banking. We used to do with the bikes also. So this banking angle we have to find out, that is banking road, what will be the velocity and the angle of banking. So when the system of the raising road is in the outer edge and the curved road, and the other one will be in the inner word, then it will say that the banking of the curved road, an angle with the outer edge, that what it is made with the raised above and the inner edge is said to be the angle of banking. So how it is given as, that is, if we have seen here that we are taking the resolutions of the resultant r, that is r cos theta and r sin theta, and the downward direction the weight is coming, that is mg. So the r cos theta will be balancing the mg. So r cos theta is equals to mg, and the force sin theta is given as f sin theta. So it will be mg plus f sin theta will be equals to that of r cos theta, and r sin theta plus f cos theta will be equal to that of centripetal force, that is mv square by r. So on dividing this both equations, we can get the v square by rg, that is the speed required for a body to move in the circular path. So from here we can write that v square by rg will be equal to the tan theta. Okay, so bending of cyclist is also there, that is whenever a body, in order to take a circular turn, the radius r, then the cycle should bend himself through an angle theta to the vertical, such that the tan theta should be equals to v square by rg. So here it will come again that the bending of cyclist, if a cycle is bended, then here the r, so resolution is given that r sin theta and r cos theta, then r cos theta should balance mg, then mg is equals to r cos theta, and the centripetal force will be equals to r sin theta. So it will be mg will be equals to r cos theta, and mv square by r will be equals to r sin theta. On dividing we can get tan theta, then tan theta will be equals to v square by rg. So the radius, or it depends on the radius as well as gravity and the speed of the cycle. So angle theta, if the speed of the cycle is large, then the theta will also increase, and if the radius of the curved path is small, then also the theta will increase. So this is the angle of the bending. So from here, these are the numericals for v square by rg. Let us calculate the angle through which a cycle should bend from the vertical when it crosses a circular path of 34.3 in circumference in under root 22 seconds. So tan theta is equals to v square by rg, and what is v? Here the length of the path by the time taken, because distance travelled upon time taken, distance will be length of the path. It is given as 34.3, circular path is of length 34.3, upon time taken it is given under root 22 seconds, so it will be 22. And we know that the radius of the path, we know that circumference is given by 34.3, right, because the length of the path is 34.3, circular path radius is circumference will also be 34.3, so circumference is equal to 2 pi r. From here we can find out the radius also. So v square by rg can be given as the angle through which the cycle should bend from the vertical. And the next one is also the same thing, but the cycle is speeding at 18 km per hour on a level road, takes a sharp circular turn of radius r equal 3 cm with it, reducing the speed and without bending towards the center of the circular path. So the coefficient of static friction, here the static friction came, that is mu. So we will be using the formula of the mu also. So it is given that mu, will the cycle slip while working the turn. So whether the cyclist will slip, we have to see this. So tan theta is equals to v square by rg, and this v square by rg is also equals to mu. So for finding out the mu, we can write it as mu rg into v square, right? So here we have taken out mu rg, so we can find out the actual speed. So should the actual, we have seen that the friction should be more than that of the actual speed. Here it is 5 meter per second. So the actual speed is greater than the maximum safe speed, so it is more than the mu. So we have already said the mu should be greater. Here the v is greater than that of the mu, so it will be slipping, so the cyclist will slip during the turn. So this is what the numericals for bending of cyclist and the equilibrium or the connected motion of the connected bodies also. So here the chapter will be coming to the last. We will be completing this chapter now, and from tomorrow onwards we will be seeing if we will getting the MCQs. Don't be tense, because after completing this chapters, I have to complete this chapters very fast, and after that I will be telling few topics that from where the numericals will come. We will be solving the MCQs also, so don't be tensed about the topics. This is laws of motion, and the next work energy theorem will be there. That is work energy and powers chapter. The important topics I will be telling you, and after gravitation is there. So 2 chapters let me complete in this 2-3 days. After that we will be solving the numericals. So if you have any doubts, you can comment down in the videos also, so that I can understand what the problem is, because if you will be asking in the group or in the classes, it will be getting into school also, that whether the portion is completed or not, whether the questions will be coming or not. So don't try to ask in the group also. Okay, so thank you class.